Hello everyone, and welcome to this video where I'll be taking you through the OpenStax.org text called Prealgebra, second edition. In particular, I'm in section 1.1 called Introduction to Whole Numbers. And in this video, I'm going to start taking you through the section 1.1 exercises. And I'll be going heading by heading, starting with the heading Identify counting numbers and whole numbers. All right, so here we are, OpenStax.org, Prealgebra second edition, 1.1, Introduction to Whole Numbers. And I'm in the section 1.1 exercises, practice makes perfect. And the heading, Identify counting numbers and whole numbers. Now, before I do these, I must ask you to please try them yourselves first. Okay, before I start a problem, pause the video and try to work out the answer on your own first. And then go back and watch me do it to verify your answers. Let's see how well you're doing, how well you're picking up the material. Because if you're just watching me do these problems and you're not doing anything on your own, there's a good chance you are not going to be grasping the material or, remembering how to do the material in the long run. So please, please, please do not just watch me do this and do nothing of your own. So, in the following exercises, we're asked to determine which of the following numbers are A, counting numbers, and B, whole numbers. So number 1. So the numbers we're given are 0, 2/3, 2 divided by 3, a fraction, 2 over 3. The number 5, the number 8.1, that's also 8 and 1/10, comma, and then the final number is 125. Okay, so hopefully you recall from the reading, these are the exercises at the end of section 1.1, so it is assumed that you've already read through the entire section, practiced the examples and the try it problems before you go into the exercises. So I'm going to say recall, that should be familiar to you. The counting numbers, right? Part A is asking you to identify the counting numbers. So remember, the counting numbers start with 1, and then just increase by 1 to get to the next one. So then 2, 3, 4, 5, 6, and so on. All right, with an ellipsis here, dot, dot, dot. So notice in the counting numbers, there are no fractions. All right, I know technically we're not supposed to know what a fraction is yet, but that is a fraction. That's 2 divided by 3, where you have a whole number, counting number, on top of a fraction bar, vinculum bar, divided by another whole number or counting number. That is not 1, right? So 2 divided by 3, 3 is not 1. Numerator, denominator. Again, you may have heard the word fraction before, but notice that the counting number has no fractions and no decimals. Now, technically, These are all decimals. You can always do 1.0000, 2.000, with zeros forever after the decimal point. What I mean by no decimals is that it's not like 8.1 here, where there's a decimal point and then non-zero numbers to the right of it. 8.1000, but there's a non-zero number to the right of it. And even 2/3, again, I know we're not supposed to know what this is, but 2/3, 2 divided by 3 as a decimal would be 0 point and then 6, 6, 6, 6 forever, and they put a little bar over here to let you know it repeats. But again, you have non-zero numbers to the right of the decimal point. That is not going to happen in a counting number. So of these, 5, all right, so part A, 5 is a counting number. I've listed it here. And then, the only other ones here that are not fractions, not decimals, notice that 0, right? 0 is not considered a counting number. So this one here, 125. Now I don't see it, but the dot, dot, dot implies that, if I kept going, you'd eventually get to, 120, 121, 122, 123, 124, 125, right? That while counting. So the two counting numbers here are 5 and 125. And then part B, they ask for what are the whole numbers. And again, let's recap from the reading what the whole numbers were. Well, the whole numbers are just the counting numbers, but starting at 0. So 0 is considered a whole number, and then you just keep increasing by 1. So 1, 2, 3, 4, 5, and so on. So yeah, the only difference is that there is now 0. So every counting number is a whole number. But not every whole number is a counting number, right? The only whole number that's not counting is 0. All right, so going through the list again, 0 is a whole number, so that's part of it. 2/3, I mentioned no fractions, no decimals, right, with non-zero numbers to the right of the decimal. So no. 5 is counting, so it is also whole. 8.1, decimal with a non-zero number to the right of the decimal point. That's neither counting nor whole. And then 125 was counting, so it is whole. Right? So here we are for number 1. Right? Part A, 5 and 125. Part B, 0, 5, 125. Now, for the odd numbered problems in this text, you'll see that there is a link on the number, right? Just for the odd numbered problems, though. You click on that link, it takes you to the solution set, right? The section 1.1 exercises answer key. And you see part A, 5, 125, part B, 0, 5, 125, as I had written. And then the nice thing about, again, these odd numbered problems is that you click right on that number again, and it takes you back to the section 1.1. You have to find the exercise again sometimes, but it takes you back there. Here we are. Now, again, that's only for the odd numbered ones. So for these even numbered problems, I guess you're just going to have to trust me. So hopefully you believe what I'm saying when I go through these even numbered problems. All right, so number 2. All right, so number 2, given the following list. So 0, 7 divided by 10. So that's one of those fractions, right? Numerator, denominator, and a denominator that's not 1, it's 10. So that's neither whole, nor counting, not counting, not whole. Then 3, then 20.5, right? So here's another decimal where there's a non-zero number, a number that's not zero to the right of the decimal point. So that's not counting, nor is it whole either, right? No fractions with denominators that are not 1, no decimals with numbers to the right of the decimal point that are not 0. And then 300. All right, so part A might be counting numbers in this list. 0, remember 0 is whole, but not counting. Fraction, neither. 3, right? 1, 2, 3. 3 is counting. And no fractions, no decimals, so not, this is neither. And then 300, right? Eventually you'd get there. 3, 4, 5, 6, 7, 8, all the way out to 299, 298, 299, 300, right? You'd eventually get to 300. But notice, right, it's not a fraction with a denominator that's not 1, right? Technically, it would have a denominator of 1 if you wrote it as a fraction. We're not supposed to know about fractions yet. And then a decimal point, could be there with just all zeros to the right. So again, this is not like one of these 7/10 and 20.5 earlier. So we're still okay, right? The denominator is not, it's just a 1 denominator, and the numbers to the right of the decimal points are all zeros. So that's okay for a counting number. Again, think about the list, 1, 2, 3, 4, 5. You'd eventually get to 300. And then the whole numbers in this list, well, 0, right? That was whole, but not counting, right? 7/10, no. And then 3, all the counting numbers are whole numbers. Every counting number is a whole number. So 0, 3, and 300. So the counting numbers are 3 and 300. The whole numbers 0, 3, and 300. Great. And again, you really can't, unless you have some sort of other solution manual for this text, can't really check the solution. You're just going to have to believe it based on what you know about the counting numbers and the whole numbers. So hopefully you believe me when I say that these are the correct responses. All right, now one we can check, number 3. So here's the list. We're given 0 again. Then 4 divided by 9, 4/9. Here's a fraction with a denominator that's not 1. So that's neither, counting nor whole again. Then 3.9. So this is like 20.5 earlier, right? It's a decimal where there's a non-zero number to the right of the decimal. That is not good, right? When you're talking about counting numbers or whole numbers, that is neither. Then the other two should be fine. We have 50, right? No fraction, no decimal. 221, no fraction, no decimal. So these are counting. All right, so part A, the counting numbers are 50 and 221. All right, if you were to write the list 1, 2, 3, 4, 5, 6, right, you'd eventually get to both of these. And then part B, the whole numbers. Well, the counting numbers I just listed are whole. So 50, 221, 221. And we've said this several times now, 0 is considered a whole number because, not counting. So there we go. And these we can check. And I would highly recommend you check your responses. Right, click on 3, 50 and 21, 221. Counting, 0, 50, and 221 are whole, just like I wrote. Click on 3 again, Brings me back to the exercises. Scroll up right there. There was number 3. All right, and then finally for this heading, right, again, we're going to go one heading at a time here, one objective at a time. Number 4. All right, so number 4, we're given this list of numbers, and you see how very similar all these problems are. But they say here, practice makes perfect. You can't usually just see things once and get it down and master it, right? You must be seeing things over and over again. Repetition is key to learning. So number 4, right, once again we see the number 0. And here's, 3/5. 3 divided by 5. There's a fraction with a denominator that's not 1. So this is neither counting nor whole. Then we have 10, which is counting and whole, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is on that list, right? And if it's counting, it's also whole. 303. Not a fraction, not a decimal, so this is counting. All right, if you went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Eventually you'd get to 300, 301, 302, 303. And then finally, 422 and 6/10, right? 0.6. There's a decimal, or there's a non-zero number to the right of the decimal point. So not counting number, not a whole number, right? Just like 3/5. No fractions, no decimals in these counting or whole number lists. All right, so part A, the strictly counting numbers in this list are 10 and 303. And then part B, right, the whole numbers in this list. 0 is whole, but not counting, right? So 0 again. And then all the counting numbers are whole numbers, right? So 10 again, 303 again. Box that in. Now, just like number 2, again, unfortunately, I cannot check the answer in the book unless you have some solutions manual. But based on our knowledge of counting numbers and whole numbers, these are the correct responses. Okay, great. And that's that for that part of the exercises 1 through 4 on identifying counting numbers and whole numbers. In the next video, I'll be taking you through the exercises where we model whole numbers. And thank you very much for watching.